Okay, nice. So hello everyone, welcome to our webinar about debugging common issues related to the Think Stack, LoRaWAN, and in general relating to how integrations should be built. My name is Adrian Mares. I'm head of engineering at the Things Industries, and I am also doing our operational side of things. And I interacted a lot with people that wrote integrations with the Think Stack. Joining me is my colleague Krishna, who is also working in operations and very heavily on the gateway side of our LoRaWAN stack. And he will also be here to answer some of your questions regarding common, let's say, issues with the LoRaWAN deployments and integrations.
Hi everyone, nice to be here. And you can use the chat option on YouTube to place your comments. And in the meantime, I went through our forum and a few other locations where people usually post support questions and questions they're struggling with. And in the time that you are filling in your questions, we can pull some from the list and try to look at them. One of the most commonly used questions working with the Think Stack is that there are people who want to run the Think Stack behind a proxy, and they want to disable TLS on the Think Stack. How can they usually do that?
So TLS on the Think Stack is not enforced necessarily. So as part of the configuration options, basically in the ttn-lw stack file, we allow two types of listeners. There is a port that by default is 1885, which is for non-TLS traffic, and there is 885, which is for TLS traffic. If you allow the non-TLS listener to be enabled there, and you just put that in the back of your proxy, things should work just fine. Just make sure that the TLS certificate that the proxy makes available is actually, let's say, a good one, a trusted one. So something made by Let's Encrypt is gonna make your life a lot easier. If you need to use self-signed certificates, that is also possible, but you'll need to configure your CLI and your stack to trust that that certificate authority that built your certificates. And as such, you should be take care with that. Take care.
Yeah, in addition, I think also on the stack level, if you're looking at configuration, every component has a bunch of listeners, as Adrian mentioned. And if you want to disable the Think Stack from doing any TLS operation, basically set all the TLS ports to empty. So empty quotes would set all the TLS ports to empty, which disables TLS on those ports completely. And then we assume that your proxy can handle the TLS traffic. Super. So another common question that is usually asked is, how do I know if my gateway is connected? And it's a two-part question which usually comes together, which is, how do I know if my gateway is connected? And the second question would be, if I want to know, if I want to list all my gateways in my account, and I want to know how many of those gateways are active or currently connected, why do I have two separate APIs? And one API seems to be in one cluster, another one seems to be in another cluster. Why do we have this?
Yeah, so this is a twofold problem related to how, well, challenge related to how things work in the Think Stack. So due to LoRaWAN, fundamentally, it's a very latency sensitive protocol. Fundamentally, if you receive a message from an end device, you need to respond quite fast. In the case of our stack, it's about 5 seconds. By default, it's quite it's more severe. It's about a second. Because of this, you are interested in having your end devices, your gateways, and the actual cluster which processes the traffic. So basically takes it from the gateway and sends it to your integration, your MQTT, your webhook, your visualization tool. You want them to be geographically close. As such, in the Think Stack, we have the concept of clusters. The cluster is a set of, let's say, servers, which are geographically closely one to another. And this basically ensures that we can process your traffic as fast as possible. Now, the trouble is that if a gateway, now, if you think about it, if you have one gateway in one location, a gateway that is identified by its EUI, you cannot have it really in two places at the same time. It's a single gateway identified by a single unique identifier. It is globally unique. And in the case of the Think Stack, this registration, because it's globally unique, it has to go via the cluster, which is central. In the case of both Community Edition and Cloud, this is EU1. So all of the registrations and basically the list of all registered gateways is going to be found in the central registry, which is in EU1. Whereas traffic statistics, which are related more to actually where the gateways are connected and where the traffic is processed, is going to be regional. So it can be the case that if you're interested in all of the gateways which are within your account, you are going to have to contact the global registry in the EU1 cluster. Whereas if you're interested in traffic statistics for a particular gateway, you're going to have to look in the specific cluster like NAM1 or Australia1. You can also know for an individual gateway which cluster it is registered on. So we have this field in the entity registry called gateway server address. And that one is the full address of the cluster, like e1.cloud.thethings network. And based on that, you can look at it and say, okay, actually, I need to get it I need to get my statistics from you or from NAM or from any other place.
Great. And also a bit more technical is that we have the Think Stack is broken down into microservices, just to piggyback on what Adrian is saying. And the service that handles your data, the registration of any entity, device, gateway, users, etc., we call it the identity server. And the microservice that handles your gateways is called the gateway server. And the way the Think Stack is architected is that we have only one identity server per network. So for the Think Stack Community Edition or the cloud, for example, you have a single identity server for each network. And all the clusters, which are regional, have to speak to to the central identity server. So that's why you have a difference in API, where if you want to list all the gateways that are registered to your account, you have to talk to the EU1, for example, the identity server. And if you want to know the gateway statistics, you talk to the cluster where the gateway is connected to, which is the regional clusters. So we have a question from Tiberio from LinkedIn regarding the implementation of a new device. What are the main things to be aware of while trying to connect a device for the first time for a custom device? And is there any source of knowledge that you can consult to make it most efficient?
Yeah, that's a good question. So in general, while looking at the implementation of a new device, I heavily recommend development kits. So not necessarily trying to do software simulation or anything crazy, just getting a LoRaWAN development kit and trying to use one of the two main at least one of the two main open source stacks. So there is LoRaMAC Node, which is quite stable and available on GitHub, maintained mainly by Semtech. There is LoRa Basics Modem, which is again maintained by Semtech, but it's a newer generation, a bit more fancy software stack available for your end device. There are lots of resources and examples available for both of these. I'm pretty sure there are some other stacks available too, which are based on Arduino or on Python. I do not have as much experience with those, but community members, as far as I'm aware, have used them with much success in the past. I recommend things like LoRaMAC Node because those are also battle tested, let's say, for production grade and devices. Like we've already had many devices in the field which are based on LoRaMAC Node, and starting with that software stack, I would say it's a good idea. Now, when you say most efficient way and without doing something crazy, which I guess in this context means wrong, do you refer with building a firmware that is most efficient power-wise, memory-wise somehow, or are you thinking of something like efficient as in it's going to be very fast for you to actually set it up? Because at least in my experience, setting up something like LoRaMAC Node for an LoRaWAN development kit, one line of compile and then a drag and drop. And that's really, really fast, in my opinion. It doesn't require much preparation ahead of time.
Yeah, and also adding to what Adrian said, if you want to maybe look at how you can optimize your device to make sure it's scalable, then either in our documentation or even if you look at the ThinkStack Cloud SLA, we expect devices to have certain ways of implementing. So the LoRaWAN standard does not define how your application layer should work. And we have certain documentation on how our experience on handling like millions of devices, and we give you some recommendation on how you can implement each individual device so they can be scalable. So that's also a place where you can look at.
Yeah,
And
so if I want to give some examples of what to think of while designing like radio-based, LoRaWAN-based end device software, my recommendation is to think as if all of your devices are all in the same geographical place and they all need to fight over the air, because that's more or less how things happen in reality. You have lots of devices spread at high range because LoRaWAN has very good coverage in the same place, and they are all sharing the same airspace. You should be ready for some messages to sometimes be lost. You should be okay with retrying them. You should be thinking of what happens if two devices need to retry at the same time. In this case, you should be thinking, for example, at exponential backoff, at some jitter in order to avoid synchronizing end devices accidentally. So LoRaWAN at scale requires a bit of thinking ahead of how devices are going to interact one with another, not just the interaction between one single end device, a network server, and then some application that collects the data, creates alerts, or visualizes it. You should really be thinking of your end devices as a fleet of devices, all of them trying to use the air, which is a shared medium, and should be ready to handle failures in that regard.
great. So a commonly asked question always is, what is the maximum data that I can transfer using LoRaWAN? What is the magic number, Adrian?
The magic numbers. In the case of LoRaWAN, the data depends a bit on the range over which we want to send the messages. So given good actual gateway coverage, we have about 230 bytes of data available at spreading factor 7. This is like, let's say, the best case coverage for a LoRaWAN end device. You shouldn't be sending probably that much data, like using all of the available space. You should be trying to compress as much as possible the information that you're sending, because if you depend on sending so much data in a single message and you have problems with the coverage, there are maybe too many devices, there is interference, you will lose a lot of messages. So you should be thinking not necessarily in using all of the maximum bytes per message, but trying to be very efficient, sending as little information as possible. Like you should use as much as possible the fact that you control both the bytes that come out of the end device and the application that processes those bytes. So a lot of information can be exchanged out of band. So we say, okay, the first byte, it's always a temperature. The second byte, it's always whether or not an alarm has been triggered. You can even use one bit for that. So having a very efficient transfer scheme, it's more important than actually using the whole data. We say, yeah, it's 230 bytes, but 230 bytes is a lot, and many things can happen to your bytes.
Okay, so the next question is, do you have any updates on native FOTA support in the ThinkStack?
So FOTA itself is a very long subject. While the ThinkStack has supported multicast traffic, which is is basically the holy grail of reliable large-scale firmware over the air updates, we do not have basically a standard FOTA server available to this date. We have all of the tools that you need in order to build one that would interact with your own particular FOTA application on the end device. So there is multicast, there is actually even simultaneous cast. So basically sending the same fragment through multiple gateways at the same time. There are many tools available which allow you to do efficient FOTA, but because there isn't, we don't really have a strict solution of what needs to be implemented on the end device. We don't have a simple server available in which you would just drag and drop and automatically 10,000 devices would be updated. In general, this is a hard problem because every end device has different requirements, has different upgrade procedures. In some cases, you can get away with just Delta updates, so changing just a bit of the firmware. In some cases, you need to do a full replacement. There are many many knobs which need to be available, which make a general purpose FOTA server hard to be implemented. But all of the tools that you would need in case you need FOTA for a specific use case, for a specific vertical that you need to work in, are already there in the thing stack.
Okay, great. And how do I know if my gateway is actually connected?
Well, that's actually a nuanced question. Are you interested if it's connected just now? Then you just look at the console. Via the Things console, you go to your console tab, and then you click on your gateway, and it's gonna say it's connected and how many messages have already been processed since it has connected, and how many messages it has sent down. Now, this tells you basically information in an instant, in a sense. You lack a bit of history on what has happened with your gateway. And in case you are looking for more historical data and more debugging data, as part of the ThinkStack Enterprise, we have a new component called the Network Operations Center, which allows you to gain access to historical data about your gateways. So moments in which it connected and disconnected, traffic rates over time, how the packets are spread over frequencies and over data rates. And in an upcoming update, which is currently under testing, we are also going to make this information available for applications and end devices. So not just looking at gateways, but also looking at end devices and applications and getting insights about those.
Yeah, super. And I think it also ties into a question about how do I keep track of my gateway connectivity? And I think that the important thing to understand first is that there is no single answer when it comes to gateways, because different gateways work on different protocols. So when you have gateways that use the Semtech UDP packet forwarder, UDP by definition, there is no concept of a connection. That's how UDP works. It's a fire and forget system. And so we have to derive the concept of a connection by doing some protocol magic. And of course, with the basic station protocol, which we recommend that you use your gateways with, it's TCP, so you have the concept of an active connection. And using that, you can know if your gateway is connected or not. Now, the problem is that a lot of the times, the gateways, especially basic station, they have really good redundant. How would you say? They can reconnect quite quickly in case there's a disconnection. So the problem with being able to immediately notify you in case of a gateway disconnection is that the disconnection could be a valid disconnection, or it could be due to some jitter in the network, or it could be transient. And debouncing that in a case where the gateway itself is a bit unreliable is quite difficult to do, which is why you really have to look at either subscribing to the status from one of our APIs or looking at through the console. Another question people ask is, I have a bunch of gateways which have external antennas, and how do I adjust the TX power of those antennas?
This is generally an operation that depends on the type of gateway that you use. So in the case of UDP gateways, this is a configuration option that you can adjust either in your actual gateway configuration in the gateway, or it's something that can be adjusted from the ThinkStack. So using the command line interface. So in the command line interface for individual gateways, we have a field called antennas. And antennas basically have a field called gain, and the gain can be positive, can be negative, and in case you want to lower the transmission power, you just have to set the gain of an individual antenna to negative value, so -2, -4, depending on how many dBm you need to bring the transmission power down. In general, this is a specific requirement, so it's rare. In order to avoid cluttering the UI, this is an operation that we don't yet make available through the console, but it's something that you can do easily via the CLI, and you can even automate if you need to do it for multiple gateways. The same operation is also available via API. So everything that in the thing stack that uses the JSON API, the gRPC API, and it's all the same. So every client that we make and that customers depend on, it's unified. There is no hidden API in that regard.
Yeah, and also one question I think is also that the one place where you usually get confused is that the TX power, when you look at the LoRaWAN specification, what is mentioned there for a particular downlink is different from what is probably set in the gateway. So you usually see that the maximum TX power is 16 dBm, for example, and if you look at the gateway, it's sending 27. Why is that? And the difference really is that the gateway transmission is not defined by the LoRa specification, it's defined by the regional one. So for example, in Europe, we use ETSI, European Transmission Telecommunication something, and they define what the maximum power that is supposed to be sent. And for an end device is where you look at the LoRaWAN specifications. So there are two separate specifications that you need to look at to understand why this difference exists. A question is there a way to disable dev nonce and the frame counter checks in TTS? And the person promises that they will use it only in a development environment. We trust your promise.
Yeah, I definitely trust the promise. I've never seen someone do that in production. A bit of jokes aside, when it comes to dev nonces, this is an option available in the console, and again via CLI or API as well. In the console, in the join settings, there is a checkbox that says resets join nonces, which in the case of LoRaWAN devices under version 1.1, it's also affect the dev nonces and should allow reuse. So that's the only thing that you need to do when it comes to joins. Now, when it comes to frame counter checks, we do not allow basically disabling the frame counter checks completely. So there is the option available that basically we accept that the frame counter may reset. And by reset, we expect that after the frame counter has reset, so let's say from frame counter of 5, it goes back to 0 or 1, we expect that the end device also has reset itself. There is this field resets frame counter, which controls this behavior. But this is not really a disable frame counter check in the sense of, okay, I received packet I received packets 5, 8, 9. And then you would be able to receive the missing packet 7. This is not something that we support today. In the old version, in what was known as the STTMv2, we did support that, but that's a big security issue, and it also creates problems in general with how traffic actually should be handled, and it's not a secure option. For development, I agree with disabling dev nonces, and in general, just using OTA, not ABP.
Super. And one question is using a LoRa. This question I can't really understand specifically, but using a LoRa gateway, is it necessary to register the gateway in LoRa community to get access? I think what you mean is, should you register the EUI perhaps, or do you need to be able to register to one of the community clusters? In which case, the answer is yes. You will have to register your gateway for the gateway to be able to forward data. And if you mean by LoRa community, you mean the LoRaWAN Alliance or the LoRa Alliance, then if you're talking about gateways that use either basic station or UDP, their unique identifier is an EUI. So it's a extended universal identifier. It's a 64-bit value. and you need to be able to possess one of these unique values for to be able to connect to a global cluster. So if you are if you buy a gateway from any trusted manufacturers, they will just assign an EUI that they own to the gateway. If you are doing a test on a Raspberry Pi, for example, you can derive a EUI from the MAC address, because the MAC address is of course unique for the Raspberry Pi, for example. So in either ways, you definitely need some kind of a unique EUI to be able to connect your gateway to make it unique. If that's the question that you're asking, if not, please be more specific. What are the cases that the device last seen it says never seen, even though it was previously active?
So the last seen functionality in the things stack, it's newer than some devices, basically. The idea is as follows. In the entity registry, in the identity server, we now have a dedicated field for every end device, which we update when a message is sent. The update is not really synchronous. It's done in the background in order to avoid slowing down traffic. And what happens is that if an end device has been active before we actually added this functionality, so something like in 2020, and it hasn't sent traffic since then, or 2021, then the last seen field hasn't been updated. It's updated only when a message comes, and it hasn't been retroactive. So when we added the functionality, we also basically started recording these last seen timestamps. Now, in case the last seen actually resets, even though like you've seen it reset recently or over the past couple of months, like even though you know a message went through, but there is no last seen updated, that could be a bug, and feel free to report it in case you have some concrete details about it. As far as we are aware, the last seen timestamp does work, however, for newer devices and for devices that have sent traffic recently.
Great. Now moving on to the integration side, a common question that I always get is, what should I use to take my data out of the things stack? I like MQTT, but you guys don't recommend MQTT. So what are my options? And why do you not like MQTT?
Yeah, so that's something that's very common actually, and it's a cause of lots of pain. So in general, MQTT, it's a nice protocol when it comes to connecting something like machine to machine. But the problem is that at scale, it's very noisy. So it requires an active connection that is there at all times. It requires buffering, so keeping in mind how many messages in case you want to actually see messages while you were not connected, it requires a form of buffering and storage. And that makes things complicated. In general, we don't like MQTT because people use it, basically, it's hard to load balance it correctly. So we have thousands of users, tens of thousands of users, each one of them connecting over MQTT. Some have a lot of traffic, some don't have a lot of traffic. And over time, as they connect and they stay connected, what happens is that the balance of how much traffic is sent is very big. And this affects basically our service levels. So first of all, the offering of a stable service level while having this imbalance in MQTT, it's quite hard. Second of all, in general, MQTT itself, we've seen it being very, very misused. So for example, people not correctly connecting or disconnecting their clients. It is not really resilient. We know in general, if you don't have if you're not connected, you're not gonna receive the message. At least in our implementation, because we don't want to do buffering for each individual client. That would require a lot of space. And in general, load balancing it also from the perspective of the person receiving the traffic is hard. There are some options. There are subscription groups available in MQTT 5, but these do not really address the fact that basically the connections themselves, the streams are imbalanced. It's really hard to make scalable systems when the data flow works as it does in MQTT, at least when it comes to like application layer data, so lots of aggregated data. What we prefer for people to use in general is webhooks. So basically, instead of you connecting to us and starting to receive the data, we prefer to push the data to you. This has lots of advantages both for us and for you as a person that wants to receive the data. In general, the idea is that we can send you the data from any server we want, so we can perfectly spread it out, and even if the traffic pattern is erratic, or even if the load per individual application is not really balanced, we can spread it a lot better on our side and give better service level to everyone. And also, you as a receiver can do exactly the same thing. You can balance it over multiple underlying servers. So having redundancy, having load balancing, a lot easier when we push the data to you than when you pull it, when you have to connect to us and receive it. So in general, we prefer webhooks because they scale a lot better both for us as senders and both for you as receivers. Any integrations that we recommend people to create, like at scale, should be based on webhooks. But we don't say necessarily, okay, web MQTT has no place. MQTT is useful during debugging. We know that, for example, if you are in a corporate environment or you're simply working behind a firewall, like most people do, it's really hard to actually have messages be sent to you. That's a real problem. And you actually want to look a bit at the data to understand what's the format, what fields are in there, and things like this. In those cases, using MQTT is just fine. Building the, let's say, the message processing via MQTT is fine. But since the message format is exactly the same between MQTT and webhooks, we recommend only developing with MQTT and actually receiving the messages while being in production via webhooks. It's a bit more work compared to just connecting and leave it in like that, but it scales a lot better, and it, in general, it's a lot less maintenance to be done once basically the setup is in place.
Excellent. So another question that come up is, what should we do if they identify a security threat, and by which I believe they mean some kind of a vulnerability in the stack? And if that is the case, of course, we have a process for responsible disclosure, and you can just follow the process. It's the same as what was available for the Things Network v2. So the same process is maintained. You just file a responsible disclosure claim, and one of our engineers will look at it. By a security threat, if you mean for a particular gateway, then you should look at it for that particular gateway with the vendor. So
Yes.
a common question that usually you get is, what are the ports that I need to allow in my firewall to work with the Things stack? And I think I can answer some of these. Mainly, it depends on the gateway that you want to connect to. Ideally speaking, if you use LoRa Basic Station, for example, and you're querying the data only via webhooks, or you're just querying our storage integration to fetch data once in a while, for example, you don't need to use any other port other than 443. LoRa Basic Station gateways work on 443, and you can also pull data out of the Things stack with our API on 443. If you need to connect MQTT, whether on the gateway side or on the application side, we have a bunch of options. So the MQTT protocol for gateways are of two types: the older legacy version, and then the MQTT message. We have changed it in the Things stack v3 with updated fields. And so you have MQTT v2 and v3, and those are available in 1881 and 1882. Application MQTT traffic, which Adrian just discussed, to take application traffic out of the Things stack would be 1883 or 8883 based on if you need DLS. And if you want to interact with our API directly, you can use gRPC, which is at 8884. And for the LoRaWAN backend interfaces interoperability, we use the port 8886. So those are the basic. We also have a LoRa Basic Station on 8887 or 1887. However, you also, because Basic Station just works on WebSockets, which is just over HTTP, we also allow the same functionality to be accessed via HTTP. So if you're in a corporate environment and you are a bit worried about what ports should I allow in my firewall, then if you choose LoRa Basic Station and you use webhooks, then you don't need accept any special ports. It's just 443. So I think Adrian already answered this question, but people do ask a lot about, there was a knock in the V2 for gateway information. Where do I find it in the ThinkStack V3?
A large part of the information, so traffic rates, gateway count, and lots of those type of, let's say, statistical information should still be available via the packet broker mapper API. So community network traffic and gateways are can be made available via packet broker. They are opt-in, they are opt-out. So by default, traffic is going to be sent to packet broker. And based on that, statistics related to community gateways can be retrieved from a packet broker. In general, you can use this API to look at groups of end devices, groups of gateways, check how many packets they have sent, some small information like identifiers. But the bulk of the information that we had available in the old NOC, like locations, names, collaborators, are not something that we currently have available publicly. So while you could use the V3 API and look at public gateways, and if you know about them and check, okay, what's the name of this one? If the user has put the location and shared it, you can also retrieve it from there. In general, getting lists of gateways is available mainly through the packet broker mapper API. More information about it at packetbroker.net, I believe.
Super. Question is, are TTI, TTN planning to drop support for the UDP packet forwarder, I assume, in the future and push all the remaining gateways to basic station? We would love to do that. We would absolutely love to not have to deal with the UDP protocol. And you should also remember that the UDP protocol, the last actual change that was committed to the GitHub repository was in 2017. So you are basically running a piece of software that is no longer maintained. Of course, some gateway vendors have forked that repository and maintained their own implementation, but the protocol itself has not been updated to keep up with the changes in the cloud environment. And the reason being that the reason is the introduction of LoRa Basic Station. So most gateway vendors, depending on the type of gateways, if the gateway is relatively recent, give you an option to update the firmware to use Basic Station. And I would highly, highly recommend using that option. And if possible, maybe contact your gateway vendors to support Basic Station on older gateways also, because the UDP gateways are quite difficult to work with, and they're also unreliable for gateway communication. We may think of having a deadline for UDP, but that's not something that we are actively considering, because of it's also about how many gateways are available that are basic. If we see in the future that 95% of new gateways are all basic station by default, and the UDP gateway is being used much lesser than it is right now, then we may consider it. But at the moment, considering the amount of gateways that are used that are UDP, I don't think we have any plan in the near future to drop support for UDP. However, we highly, highly, highly recommend that if you're either starting a new project or if you have the opportunity to switch to basic station, please do that.
Yes, in general, we try to push to be the change you want to see in the world. So in that regard, our support of Basic Station, we try to support every important feature in Basic Station. We try to make onboarding Basic Station easy. So for example, over time, we made sure that onboarding Basic Station gateways is easier. So right now, the onboarding flow, when you register a gateway, allows you to like automatically create all the keys that you need in order to onboard a Basic Station gateway with ease. We make sure that we don't have regressions as much as possible. So we have lots of Basic Station gateways that we do tests with. And as Krishna said, would love to see more gateways move to Basic Station as much as possible. On the other hand, we realize that there is a legacy out there and that it could be quite costly for many people to upgrade their gateways. What do I do if my gateway vendor no longer exists? In that case, I don't really have that much of an option. But for new deployments, for ongoing updates, for refurbishing, we always recommend trying to use Basic Station. It's simply the more secure and we argue also more scalable solution in the future. So, for example, one of the important features of Basic Station is cups, which basically allows you to remotely configure your gateway to a certain extent. So you can choose which channel plan you want to use over your gateway without having to directly connect and configure it. You can just change the frequency plan in our console and it propagates to the gateway. You can choose to which network server it connects. So you can basically have your gateways point to another LoRa network server without having to configure them. It's more robust than the UDP packet forwarder, but given the legacy, we can't really throw it out as things stand today. The UDP packet forwarder is a thing everyone has to deal with, but we definitely push people to abandon it if possible.
Yeah, indeed, that's right. And actually, there's a related question, which was my next one, is people would like to know how they can connect their Things Indoor Gateway, which is based on LoRa Basic Station, to their private networks or to their laptop for testing. And this is actually documented in our documentation. But the basic idea, as Adrian said, is LoRa Basic Station has a protocol called CUPS, which means that the gateway, by default, as soon as it turns on, connects to one server which maintains the configuration of that gateway. So you can configure this server, which is the initial server, to tell the gateway to connect to wherever you want to do. And so what we do with that is that we allow the ThinkStack to claim these gateways. So that's a concept we call claiming, where the concept of registering a basic station gateway, especially a TTIG, we call it claiming. And the difference basically here is that if you have the gateway and its password, you claim the gateway, which means you can send configuration from the network side down to the gateway. And that's one of the disadvantages with UDP. The UDP protocol is that the configuration is via a JSON file, and you need to find some other way to inject this JSON file into your gateway. And if you have a few thousand gateways, you either have to have a third-party management system to SSH or send configuration to each gateway, or you need to do that manually. But with Basic Station, all of this is part of the protocol itself, which means that we can push down the credentials, the frequency plan, and also if you want to change the location where the gateway is connected, you can once again push it directly down from the server side. So with that context, you can claim the gateway on one of the ThinkStack distributions, the Community Edition or the ThinkStack Cloud. And you only need two things for this, the EUI, which is on the back of the gateway, and the Wi-Fi password, which access the claim authentication code, which is the authentication part. Once you claim the gateway, the ThinkStack itself knows how to talk to this gateway, so it will automatically connect to that cluster. And once your gateway is claimed and connected, now you can just use the ThinkStack console to tell the gateway to connect to somewhere else, and you can set all the configuration that you need to directly in the gateway general settings page. And this concept has been documented in our documentation. So if you look through our documentation, this is clearly documented. The only thing you need to note is that you need to first claim your gateway on one of the distributions. So then the ThinkStack Cloud, one of the ThinkStack Cloud or Community Edition, one of the clusters now has access to that gateway. And once you have access to that gateway, you can use that console to reconnect it to somewhere else. Okay, maybe one final question, because we don't have any much left in the chat. How can I track the airtime consumption of my devices? Do you have any tools for that?
In general, the airtime usage is really low, so that's the simple question. As part of the upcoming Network Operations Center update, we will make this information available. So the historical airtime usage for both singular end devices and probably for applications as well. In general, our recommendation are to not use the airtime as a target metric. So thinking, okay, I'm just going to use the airtime as long as I'm under a certain percentage, I'm gonna be fine. That's even though there are airtime limitations regulated in the case of ETSI, the recommendation is to realize that that the air is a shared medium, that some messages will be lost, that some messages will be sent at the same time, and that you shouldn't you should try to send as little information as possible, and depending on your requirements, as rare as possible. It's even though you're going to be under, let's say, regulatory limits, the regulatory limits are quite high, and you should avoid hitting them in general, not because you're breaking the law, even though that's a very good reason, but rather because once you're going to have more devices in the same area, you're no longer going to be able to send traffic. You will experience lots of loss, which comes mainly from the fact that you're overusing the air. So our recommendation in general is to be very careful and when you transmit messages and how much data you transmit. The actual airtime, how much airtime you spend, it's not the type of metric which you should target. Just because the airtime is low does not necessarily mean that everything is gonna pass through, because you're basically looking only at the airtime spent by your device, but your device is in a shared medium, so it's gonna have to fight with the other devices too. And in general, design should take into account this whole idea that you are going to have multiple end devices which are very high range. LoRa fundamentally is high range compared to other technologies, and because it's high range, you're going to have lots of overlap, and the overlap is going to be what is a challenge in case you need to send too much data too often.
Okay, great, fantastic. So just to close the discussion, I think the best place that you can ask more questions is the forum. So you can just go to thethingsnetwork.org/forum, and you can continue the discussion there or ask different questions that you have. And also you have a search function where you can search for previous threads where you have information. Documentation to work with the ThinkStack itself is found in the thingsindustries.com/docs. It's apparently on my profile in the live stream, so you should find it there quite easily. And for Packet Broker, the link is already there. And so we hope that you can find your information there. And members of the Things Industries and also some volunteers from the community are usually found on the forum, and we will try to help you out with your questions. So there are no more questions in the chat, so I think this is a good place to wrap it up. Thanks a lot, Adrian, and let's keep in touch on the forum.
Yeah. Thanks everyone for all the questions, and hope to hear from you soon. Have a great day.